Hello everyone, this is example number 11 from R.S. Aggarwal, Continuity and Differentiability chapter. You will find it 339 page number. If you have a different edition, you may have 2 or 3 pages forward or backward. Okay. So here is the question. Fx is 1 minus cos 2x by 2x square when x is not equal to 0. And it is when x is equal to 0, then value is k. So they have given that it continues at 0. So you have to find k. Okay. To solve it, we need LHL and RHL. So for LHL, what do we write? Limit x is tending to 0 minus. I hope you remember that. For LHL, 0 minus fx. So when it is not equal to 0, little bit less than 0, we will take this one. So it will be, write down, limit x is going to 0 minus 1 minus cos 2x by 2x square. And if you remember, what is the formula? Cos 2 theta. We have two formulas, correct? Cos square theta minus 1 if this is theta. Similarly, there is one more formula, 1 minus 2 sine square theta. Using these two formulas, we have two more formulas, right? 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sine square theta. If you rearrange these two formulas, we get these two, right? First one will give 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sine square theta. Please always mention formulas what we are gonna use. So here I am going to use this formula here. You can see, right? To simplify. So limit x is tending to 0 minus, it is 2 sine square x by 2x square. Can you see that? If it is theta, then we use theta. If it is 2x, then we will use x. Here 2 and 2 cancel. Perfect. So this is, we are getting limit x tending to 0 minus sine x by x square. Correct? We are getting sine x by x square. Now you see here, there was a limit formula, one standard formula, limit x is tending to 0, sine x by x is 1. So here it is matching, if we see. So there is no need to use any formula or H method or anything else. We can observe directly we are getting this form here, right? It is a square. So answer will be just 1 square, which is 1. So LHL is solved. Directly we are getting 1. Now similarly, let's solve RHL. Or instead of solving RHL, we can just see the function value, because function value is directly given, correct? So instead of RHL, let me write function value itself. So function value itself at 0 is k, and LHL we just calculated is 1. So there is no need of RHL, though if it is continuous, RHL should be equal to LHL, should be equal to F0. Correct? If we already have LHL and F0, so we can use it, this and this. So I can write k is equal to nothing but 1. This is my answer. Let's see next question. This is the question number 12. You will find at 339. R.S. Aggarwal. So here, this is the question. So if it is continuous at x is equal to 0, so what should happen? LHL should be equal to RHL, should be equal to function value at 0. Okay. So it is just similar to previous question. Let's find out LHL. So it will be limit x is tending to 0 minus, LHL means 0 minus f of x. f of x, which one we will take when it is not equal to 0? 0 minus means it is not equal to 0, very close to 0. So we will take this 1 minus cos 4x by 8x square. Now as we know that there is a formula, 1 minus cos 2 theta is 2 sine square theta, right? This is a formula that we know already. This is the formula. So if it is 2 theta, this becomes theta, half of the angle. Remember, right? If it is 2 theta, it becomes theta, half angle. So if it is 4x, so what it will become? It will become limit x is tending to 0 minus, it will become twice of sine square 2x by 8x square. Why? Why this? Tell me. Why we are getting 2x? Because half of 4x is 2x. Correct? Let's see, there is a formula limit if x is tending to 0, sin x by x is 1. This is the formula. But remember one thing, this formula is valid if this x and this x are matching. That means this formula has multiple forms. Means this formula is valid for, I'm sorry guys,